So this first lab, I want you to actually get started on tonight. If we were in class, this would be the setup that I would kind of show you. I have these two carts, and clearly this one kind of looks like it's heavier than the other one because it has this attached mass on top of it. And this one here has this little plunger that kind of shoots out, and they'll be able to explode away from one another. And what I want you to notice is when I get them to explode away from one another, they kind of explode away differently. Okay. I'm hoping that you saw this one here was quite a bit faster than this one over here was. And I'm pretty sure most of you probably would have expected that if I would have had you guess which one would be faster. But what I'd like you to think about is there's probably some kind of proportionality there. If you're thinking about the speed of this one compared to the speed of this one was faster than this one was, but yet this one over here had more mass than this one over here was. So in this lab, really what I want to do is I want to investigate the ratio of the masses. So it doesn't really matter which one you call 1 and 2 or A and B, but let's say the ratio of these masses, so ratio of mass A compared to B, and compare that to the velocity of A compared to B. So we're comparing ratios. The ratio of the masses compared to the ratio of the velocities. So let me go ahead and do this one more time. And so that shoots off. And so we compare the ratio of that mass to this mass compared to the velocity of this velocity compared to that velocity. And that's what we would plot. And of course we would need 6 data points. In the lab, the way we could get 6 different data points is we could change the masses. We could take this off so they're closer to the same mass. It won't be exactly the same, but pretty close to the same. And again, we would look at the ratio of the masses compared to the ratio of the velocities. And we could put different masses on them and get different mass ratios and get different velocity ratios. Well, to save time, we're not going to do this lab in class. We're going to do a simulation, but it does the exact same thing. You're going to have 2 blocks, a red block and a blue block that kind of explode away from one another, and you can change the masses, and that will have an effect on the velocities. And you're going to compare the ratio of the masses to the ratio of the velocities. Now when you're plotting this, do you think it's the mass that's the dependent, the ratio of the masses that is the dependent, or do you think the ratios of the velocities are the dependent? Okay, I'm not going to really tell you. I want you to really think about that yourself. And what I want you to do is come in to class tomorrow after doing the simulation and getting the data points. There's only 6 of them. I'd like you to have it graphed. I'd like you to have it linearized if it needs to be linearized. And that way when you come in class tomorrow, the day after you just took the one test over uniform circular motion, universal gravity, you can go ahead and plot this relationship so we can get going right into this lab. Okay, that's it.